Good morning, students.
Morning.
Good morning.
What we are, I'm
Morning.
fine. I'm fine.
Morning.
What we have seen in our yesterday discussion, with what we have
About
seen
uniform acceleration.
about what?
Uniformly accelerated motion.
Uniform
About acceleration
acceleration.
and okay. Uniformly acceleration motion. Yeah. Under uniformly acceleration motion, we have seen acceleration. Acceleration is the type rate of change of velocity, and uniformly accelerated motion is a motion of a body along a straight line with constant acceleration. Okay. In our today's discussion, we are going to start new chapter about force and the Newton's law of motion. That means chapter 3. Chapter 3. Under this one, we are going to see what is the definition of force, type of force, and Newton's law of motion. Okay, Newton's law of motion. Therefore, when we talk about motion, force is a pull or a push or a pull exerted on a body by another body. For example, if you push a table, or if you pull a table, or if you pull your textbook, you exert a force on a table on your textbook. Okay. Therefore, force is a push or a pull exerted on a body by another body. So, force is vector physical quantity. Force is vector physical quantity. That means it is described by both magnitude and direction. Both magnitude and direction. Okay, both magnitude and direction. Therefore, force is a vector physical quantity. Okay, force is a vector physical quantity. Another way, to fully describe force acting on a body, you must describe both magnitude and acceleration. For example, look, 10 Newton due to north, 5 Newton due to south, 19.6 due to west. For example, when you wanted to describe force, you must describe with a fully, you must describe with magnitude and direction too. Because of what? Because force is vector physical quantity. Vector physical quantity. We can classify force into two. We can classify forces into two, as contact and non-contact force. Do you know what is contact force? What is contact force? Do you know? What is contact force? For example, contact force.
All forces exerted when two objects are in touch or contact.
Yeah, in touch or in contact. Exerted. For example, if you push table towards to down, you apply a type of force. What type of force? A contact force. A contact force. And non-contact force is exerted without what? Without contact or without touch each other. Okay, without touch each other. Therefore, contact and non-contact force. Okay, we can classify the force or types of force. That means there are two types of force: contact and non-contact force. Okay, contact and non-contact forces. So let us see it is definition with example again. For example, contact force are forces that are exerted only when two objects are in contact. They must be in contact. For example, friction force. Do you know friction force? We will see this one under after we will see Newton's law. We will see friction force. Friction force is a type of contact force. When two bodies slide on each other, friction force is formed. Friction force is formed. And pushing a table, as I have said first, pushing a table is a contact force. Force exerted by compressed or stretched spring is a type of what? A type of contact force. a type of contact force, and force exerted on a bone by contraction of muscles. For example, when the muscle contracted, when the muscle of the bone is contracted, that muscle exert on a bone contact force, okay? Contact force. Therefore, contact force are exerted only when objects are in contact, when bodies are in contact, okay? Therefore, you must understand it is definition with it is example. You must understand it is definition with it is example. Have you understand what is contact force mean?
Yes.
Yes.
Therefore, you must know it is definition as well as it is example. The examples of contact force. The second one is, as we have read first, non-contact force. Non-contact force are which act without contact, without body contact, and also force act from distance, from distance. This non-contact force can act from distance. For example, if you take magnetic force can act from distance. Magnetic force can act from distance, and gravitational acceleration. For example, if you put something on certain heights, the gravitation attracts that body because of there is gravitational force. Gravitational force is a type of force which is non-contact, and electric force. Electric force is a type of non-contact force. Therefore, non-contact force are exerted or acted without body contact, okay? Without body contact. So, electric force, magnetic force, and magnetic force are, gravitational force are what? Non-contact force, okay? Non-contact force. Therefore, when we classify the force into two, they are contact and the non-contact force, okay? Try to identify their examples and their definition. The other one is effects of force. What do you know about effects of force? Effects of force. What do you know? Yes? What do you know about effects of force? When you exert a force on an object, there is some effect. What is the effects of force? What is the effects of force?
The
Yes,
body
change.
may change its shape or size.
Okay, change the shape or size, one. What about the second one? Change the magnitude and the direction of applied force, okay? Apply the motion. Force can change the magnitude and the direction of motion of an object, okay? Motion of an object. For example, there are, when force exerted or applied on a body, there are the following effects, okay? The following effects. For example, change in shape and the size of an object. That means deformation. For example, we can say this one, deformation. Deformation. Deformation can be permanent, or temporary. Okay? Deformation can be permanent or temporary. For example, if when you apply a force on paper, you can cut or you can change the shape and the size of the paper or whatever. So if you cut paper into pieces, it is permanent deformation. For example, if you apply on a spring, if you apply a force on a spring, after you release it, it takes the shape of its first shape, okay? It takes the first its shape. That means temporary deformation, okay? Temporary deformation. Therefore, change in shape or size is what we call deformation, okay? Deformation, deformity. When you apply a force on a body, you that body can change shape and the size of the body. Change in shape or the size of the body is called deformation. Okay, deformation can be permanent or temporary. Permanent or temporary. The other point, force can change magnitude and the direction of motion. Magnitude, and the direction of a moving body or the motion of an object. That means when a force is exerted on a body, when a force is exerted on a body, a stationary body starts its motion. For example, if one body is at rest, one body is at rest, when you apply a force on that, that body can start its motion. Okay. For example, if you take a stone and you apply a force on it, you can throw it. You can throw it. Therefore, a force can change the state of motion. Okay. Generally, when we generalize the state of motion, that means stationary body can start its motion, a moving body can increase its speed, and a moving body decreases its speed gradually, stop it is moving. For example, if one ball come to you with some speed, if you apply a force on that ball, you can stop its motion. You can stop, or you can make us it become stop. Therefore, a moving body decreases its speed or gradually stop when you apply a force on it. A moving body can change its direction. For example, when you apply a force on a moving body, you can change its direction. For example, if one ball come to you with a certain speed to north direction, you can change as it go back to south direction. Therefore, this one is the effects of what? The effect of force. The effect of force. So, effects of force are force can change the shape and the size of an object, what we call deformation. A force can change the magnitude and the direction of the motion of an object, okay? The motion of an object. So this is the effect of motion, the effect of force, okay? The effects of force. Clear? I think this one is clear for you.
Clear.
The other one.
Clear. Yes, clear.
Okay, the other one is okay. The other one is measuring force. The device we used to measure force is spring balance. Okay, spring balance. What about the what instrument we use to measure mass? Do you remember?
Imbalance.
Bean balance and the spring balance are different. They are not the same, okay? They are not the same. For example, spring balance, we can say Newton meter cube. For example, Newton meter is the scientific instrument used to measure the distance, the force applied on an object or on a body, okay? Therefore, measuring mass is a force is measured by using an instrument called spring balance. Spring balance, and the Newton meter is the scientific instrument used to measure
force.
Yeah, and then the SI unit of force is what? Newton. The SI unit of force is Newton. Okay, so in our above discussion, we have seen force. What is the definition of force? Type of force and the effects of force. Okay, effects of force. Okay. So in this case, you must know what is the definition of force, type of force as contact and non-contact. When you exert a force on an object, what you will see, or what we call effect. There is some change you will see on the body, which is forces exerted. Okay, which is the forces exerted on it. So. So this one is what we call effects of force. The other point we are going to see is Newton's law of motion. Newton's law of motion. What do you know about Newton's law of motion? What do you know? Hmm? What do you know? Newton's law of motion. For example, we have three Newton's law of motion in our physics. Newton first law, Newton second law, and the Newton third law. Okay. If you remember, and if you remember in our unit one discussion from famous scientists, Newton is one of the famous physicists in our world.
Yes.
For example,
He discovered the
Newton
law of
discovered
gravity.
laws of motion and the laws of
Gravity.
gravity. So we are going to see
Galileo Galilei.
Newton's law of motion. Okay, what he discovered, we are going to see. For example, Newton first law. We will focus in our today discussion on Newton first law and the Newton second law. Okay, Newton first law and the Newton second law. What do you know about Newton first law? What do you know about Newton first law?
Newton's
What
first
do
law
you
is
know?
called
State
is
about
also
what?
law of inertia.
Law of inertia, one. Law of inertia, and what about that?
Is the motion of a body along a line?
Okay, thank you. For example, if you take a body at rest, if you do not apply a force on it, it remains at rest. Okay, it remains at rest. And a moving body, if a moving body will continue its motion on a straight line unless an external force applied on it. Therefore, this one is deals under Newton's first law. So, Newton first law of motion states that look, an object at rest remains at rest, and a body in motion continues its motion with a constant speed on a specific direction unless unbalanced force or net force is act on it. Have you understand? If a moving body will continue on a straight line, and a body at rest remains at rest unless unbalanced force or an external force applied on that body. So Newton first law state about this one. Okay, and Newton's first law known as by the name of law of inertia.
Inertia
What is inertia, by the way? Inertia is what?
is a property of matter to resist change in state of motions.
What this means? For example, inertia is the property of matter to resist change in state of motion. What this implies? What this statement implies? What do you know about this one? For example, Newton's first law is known as by the name of law of inertia, and the inertia is the property of matter to resist change in state of motion. This means what? For example, do you know? For example, a moving car and a moving ball. If you want to stop its motion, which one is easy for you? Which one is easy become stop for you if you apply a force on it? A moving car and a moving ball. Which one is easy for you to stop its motion?
Moving ball.
Moving ball.
A moving ball. Okay.
A moving ball.
Because of what? There is some reason. Okay. There is some reason. For example, if you wanted to stop a moving car, it opposes you. It resists you to stop. For example, again, if your car is at rest and you sit on the chair of your car, when you start your motion, your body become back or to the front. For example, you sit in the car and your car starts its motion. Your body balance is towards to back or towards to front? Towards to? Yes. Haven't you seen this one? Huh? Towards to the back. Therefore, your body resists to start motion, okay? Because of it was in at rest. So it wants to continue at rest. It wants to continue at rest. Again, while you are in motion, maybe while you are in motion, maybe your car will stop suddenly. Huh? Your body balance is towards to front or towards to back? Yes? No one? Towards to the front. Why? For your body was in motion, it wants to continue its motion along straight line. So its inertia resists the change state of motion. That means a body which is at rest wants to continue at rest. A body which is in motion wants to continue, it is more in motion, okay? In motion on straight line, okay? So this one is the property of matter, what we call inertia. What we call inertia. Have you understand what is inertia mean? Yes?
Yes.
What is inertia mean? And
Yes.
concerning with this one, mass is the measure of inertia. Mass is the measure of inertia means big mass has, this means big mass has big inertia, okay? Big inertia. And the small mass has small inertia. So mass is the measure of inertia. Mass is a measure of inertia. As I have said first, if you wanted to stop a moving car and a moving ball, you can stop in easily moving ball. Why? Because of what? Because of their mass is different, okay? Because of their mass is different. Have you seen? And the inertia of a moving body depend on the mass of the body. That means larger mass has more inertia and smaller mass has smaller mass has smaller inertia. Okay? Smaller inertia. So the inertia of a body depend on a mass, okay? Depend on the mass. Therefore, Newton's first law is known as by the name of inertia. Known as by the name of inertia. And what inertia mean? And under Newton's first law, you must know what Newton's first law states. And what is inertia, and the relationship between inertia and mass. You must know. Okay? You must know this one.
Okay.
Okay. The other one. Let us see Newton's second law of motion. Newton's second law states about the direction, the relation between acceleration and the force, and the relation between acceleration and the mass. So it is said about acceleration of a body is directly proportional to force applied on it and inversely proportional to the mass of the body which on the force is applied. Have you seen? This one is, for example, acceleration is directly proportional with force, and the acceleration is inversely proportional with mass. Acceleration is inversely proportional with mass. Therefore, acceleration is equal to, in this case, force over mass. From this one, force is equal to mass times acceleration. Force is equal to mass times acceleration. So Newton's second law states about acceleration is directly proportional with force and inversely proportional with mass. And this law is known as basic law or fundamental law. Basic law of motion. Basic law of motion. This one is basic. It is known as by the name of basic law of motion. Why it is known as by the basic law of motion? It is valid from atomic level up to celestial body like planet, galaxy, and etc. It is valid. It is valid. Newton's second law is valid from the atomic level up to celestial body like planets and the galaxy and etc. It is valid. Therefore, it is known as by the name of basic law of motion. Therefore, in Newton's second law, you must know that the relationship between acceleration and the force, mass and the acceleration, as well as the equation or the formula of Newton's second law. Okay, you must know this one. You must know this one. Under Newton's second law, we can see about what? We can see about weight and the mass. What is weight mean? What is mass? We have seen about mass in our previous time when we measure mass. When we measuring mass, we have seen. But in this case, the difference between mass and the weight is vary or different from place to place. Mass is constant at everywhere or at every place. Mass is constant. For example, weight is a type of force. A type of force. For example, weight is pull of. Have you seen? Have you seen? Weight is the pull of the earth on an object. Earth attracts an object. So the pulling of the earth on an object is what we call weight. And it is gravitational force, okay? It is a type of force. What type of force? Gravitational force exerted on a body by the earth or other massive body. So force is a gravitational, weight is a gravitational force, and it is expressed in Newton. That means it is SI unit is the same with force Newton, and the pull of gravity acting on a body is towards to the center of the earth or downward. The pull of gravity acting on a body is towards to the center of the earth is what we call again weight. Okay, weight is equal to mass times gravitational acceleration. Gravitational acceleration is constant. Gravitational acceleration is constant. 9.8 meter per second square. Meter per second square near the surface of the earth. For example, G is constant everywhere. G, gravitational acceleration is constant, 9.8 meter per second square as the surface of the earth. But like on the moon, 1.6 on the surface of the moon. 9.8 is on the earth, and on the moon it gives for you 1.6. This means, for example, on the moon surface, the weight of a body is 1/6 of that on the earth. Therefore, weight is different from place to place, but mass is constant, as I have said first, at everywhere. On the moon surface, the magnitude of gravitational force is 1/6 of that on the earth. For example, if the weight of the body or what we call gravitational force, for example, weight is equal to 18 Newton on what? On earth. On the earth. What about on the moon? What about on the moon? 1/6 of this one means 1/6 of this one means 18 divided by 6 Newton on moon surface. On moon surface. This becomes 3 Newton. This shows weight is different from place to place, okay? Weight is different from place to place, but mass is constant. Mass is constant. Do you have any question which is not clear for you on this one? Do you have any question?
No. No.
Okay, I think this one is clear for you. So under Newton second law, you must know the equation which is force is equal to mass times acceleration, as well as about weight and the mass, read it, and then what Newton second law states. It said about the relationship between force, acceleration, and the mass. It's state about this one, okay? They state about this one. I think this one is clear for you.
Yes.
Yes.
So, let us see one example or two examples which is exist on this board. Example number one, look, what's the force required to accelerate a moving body of mass 4 kilogram at 5 meter per second square? Are we using this question? Are we using?
Yes, we are saying.
Try this question. This question is directly related with Newton's second law. Newton's second law. Given, required, and the solution.
Solution.
Try. What is the force required? What is the force?
MA required.
What is the formula of force?
MA.
MA means mass times acceleration, not only A, mass times acceleration. Therefore, you do have mass 4 kilogram. What about your acceleration? 5 meter per second square. And the required is force. Force is equal to how many? Force is equal to mass times acceleration. Instead of mass, substitute 4 kilogram times 5 meter per second square. So 20
In
kilogram meter per second square. Have you seen? But look, kilogram meter per second square is equal to Newton, okay? Newton. Therefore, Penny Newton is the force required. The force required is 20 Newton, okay? 20 Newton. Clear?
yes.
Huh?
Yes.
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 And check for acceleration. For example, acceleration is equal to force over mass.
Mass.
What is your force? 20 Newton divided by 4. It gives for you 5 meter per second square. 5 meter per second square.
Second square.
Okay, question number 2. If a force of 2000 is applied on a car of mass 1000 kilogram, calculate the acceleration of
The car.
Okay, find this one. Find this.
Can I answer?
Yes.
2 meter per second square.
2 meter per
Per second
2
square.
meter per second square. It can be. It can be. We will see together. Okay. We will see together. Another? Is there another question? Answer? Huh? What do you have? You do have force. Force is equal to 2000. Mass equal to 1000 kilogram. Required is acceleration. Acceleration is how many? Acceleration
Over mass.
is equal to force over or force divided by mass.
Mass.
Therefore, 1 Newton means what? What is 1 Newton? Newton. I have said in question number 1, or example number 1. For example, look, Newton divided by 1000 kilogram. You can cancel 30 by 30. You can cancel it. Then Newton means, look, Newton is equal to kilogram meter per second square. Therefore, 2 kilogram meter per second square over kilogram. Kilogram cancelled by kilogram, you will get 2 meter per second square. Yeah, the acceleration of a body. The acceleration of the body. The acceleration of the body. Okay. Let us add 1 question or 2 questions for you. Let us add 1 question or 2 questions for you. Look this one. Question number 3. What is the weight of a boy whose mass is 40 kilogram? Use 9.8 meter per second gravitational acceleration. Use 9.8 meter per second square. What's the weight of this boy? Calculate this.
192.
200? 290?
No,
92?
392.
Okay, okay. You will see together. Is there another answer? Another answer? Is there?
No.
No? Okay, let us see together. So, mass. How many do you have? Kilogram. Gravitational acceleration 9.8 meter per second square. So required one weight. Okay, weight is equal to mass times gravitational acceleration. Therefore, 40 kilogram times by 9.8 meter per second square. If you multiply, if you cancel this one, it will become, okay, issue times 98 kilogram meter per second square. 32, 300 what? 392, okay? 392 kilogram meter per second square, which is equal to 392 Newton. 392. This one is on the earth because of the given gravitational acceleration is 9.8 meter per second. If you calculate this one on the moon surface, you can divide the given or the calculated weight by 1.6, okay? Okay, there is question number 4. We will continue next spread. I think in our today discussion, you have understood many points. Therefore, I will stop on this one. Try to read again for today. Goodbye. Enough. See you next time. Okay?
I have a question. I have a question.
Okay. What type of
Question.
question? What type of question?
Mister,
Yes.
Mister, in our
Yes.
in our last period, you told us that acceleration equals velocity minus
Final velocity minus initial velocity divided by time. Yeah.
yes. In
your
this
time.
lesson, you told
Yeah.
us that acceleration equals force over mass.
Okay, in case of Newton's second law, acceleration is equal to force over mass. You can, because of how you can calculate as the question given for you. If it is given for you as given for you, initial velocity and the final velocity is given for you. You can calculate final velocity minus initial velocity over time. If force and the mass is given for you, you divide force by time and you will get acceleration, okay? Depending on the question given for you, okay? Have you understood what I have said?
Yes.
Thank you.
Yes, sir.
I will now show you